Hey guys, welcome back. Okay, before we get started, let me just say I'm not doing this at my usual time. I'm actually doing this after work, so if I sound a little tired, forgive me. I usually like to do these to record videos early in the morning when I have the most energy, and also when there's less traffic noise outside my window. My window in my office is right outside a major road, so I usually like to get these things done early in the morning. But right now it's kind of mid-afternoon, and there's going to be a lot of noise out there, so forgive me for the any ambient noise you guys might hear outside. I'm kind of expecting this to be a relatively short episode, actually. I've got my list of things to do, but they should be pretty quick, I think. So let's get into it. Today we are going to deal with the memory block class and getting memory blocks put into place, at least in a kind of rudimentary fashion. By the time we're done today, we should have a working memory block thing that we can do. But it won't be totally functional, but it will work. Okay? So, before we get into that, though, what I want to do, let's start off by, let's see, under build, I think. Let's clean the solution for just a second. I want to get a completely clean rebuild of the entire solution. So let's rebuild. So what I want to do here is take care of that 64-bit bug that we had before. So let's switch this over to 64-bit, and let's actually rebuild that. Let's see, let's rebuild that, because that might give me different warnings. What I'm about to demonstrate here is a really good reason as to why you should not ignore your warnings, like I've been doing. I've been really bad about that. Usually I don't, but in this particular case, when I'm trying to keep the video going, I haven't really been getting into the warnings. It's much more difficult to fix warnings and bugs, for that matter, when I'm trying to keep a video going than it is when I can stop and look at the code. As soon as I stopped last week's episode and actually looked at the code for a few minutes, it became pretty obvious why we were getting the 64-bit bug crash. And I'll show the crash to you guys in case you have forgotten. So as soon as we run, we get this access violation. If we're in 64-bit mode, it works fine in x86 mode. So let's stop that, and I'll show you what's going on here. So let me just make sure that I know what I'm doing here. Okay, so if we look at our error list, it doesn't have our warnings up, does it? I guess it clears them out once you run the game. That's kind of weird. Okay. This right here is basically... is it this one? This might be one of the reasons. But it's not the primary reason, I think. The reason we're getting this crash is because right in here, where I did a reinterpret cast to an unsigned int of the original. Original is a void star, which is, and so in 32-bit mode, the size of this pointer is going to be 32 bits, right? Or 4 bytes. 8, 16, yeah, that's 4 bytes. Which will fit inside of an unsigned int. However, in 64-bit mode, this actually becomes 64 bits, which is 16 bytes, and it will not fit inside this integer. That's why it's crashing. Okay, so that's the reason why we're getting all these issues. So let's see, what do we got here? Oh, there we go. Got 43 warnings. 43 warnings, 0 errors. So the compiler is telling us that this is potentially a problem. It doesn't give an error because there might be cases where you want to do that for whatever reason. I don't know why, but you might want to do it. So, but yeah, that's the reason. That's the reason why we're crashing. It turns out there happens to be a built-in type that handles conversions between integers and pointers, and it's called int pointer t. This one right here. So we're going to change that to that. And that should be good right there. That should be all I need for that for the moment. Let's rebuild that and see what it does. That should reduce my errors by, or my warnings by 2. So very good. Okay. Let's see if we can start fixing some of this stuff. So let's get rid of some of this kind of thing. So this is the same thing. This is an add new pool in the memory manager class. So let me take a look at that. Just to make sure I know what I did. Yeah, it's the same thing. Okay. So we'll change this over to int pointer t, like such. In fact, let me just copy that because I'm going to use it a couple of times. Then yeah, we'll deal with this in a minute. Okay, is that the only 2 places? I think that might be it. Let's rebuild that again. Okay, just by taking care of those 2 things, I think, if I'm not mistaken, no, it still continues to crash. Okay, never mind. All right, let's go back and fix all the rest of them. Let's rebuild so I can find my errors. Let's get rid of all these sprintf errors. I'm going to change this from D. Instead of using D, I'm going to use P. And what that's going to do for us is just, it's going to get rid of this warning, because we're not going into decimal. P is the character for pointers. So let's get rid of those. Make sure we get them all. You get a lot of warnings every single time you do that. So we'll do it here, here. Okay, let's do it again. See how many we got left. Okay, we're down to 25. That's not bad. So it's just a question of finding them all and fixing the warnings. And actually, this, I guess, is probably also causing the program to crash on me. So we'll go ahead and fix that. All right, let's just go ahead and rebuild it so I can find them. Okay, what do we got here? Okay, I'll deal with that in a minute. Okay, we got them here, here. Actually, since this automatically goes into hexadecimal format, we no longer need these extra ones, so we'll get rid of that. The percentage %P symbol automatically puts it into hexadecimal, so we don't need to worry about doing it twice like we were doing. So let's see how many we got left. Pretty good, guys. We've almost got rid of all of them. Let's we may have a crash right here. Let's run it and find out. Yeah, we probably do. I hope we don't end up with a crash, even after I fixed all these, because I didn't want to move up with my scrap codes. That would be bad. But let's find out. Okay, aligned malloc. So that's going to be in memory manager class. Let's see what we did there. Okay, guys. I think what I want to do here, I want to change this this really shouldn't be a size T. It's not really, it should be an unsigned int. So let's change that in memory manager class. Let's see what that does. I think that might, okay. We're still getting a crash. Okay guys, so let's go and fix this warning. Right. Right at the moment, I think what I want to do right now for just a second, guys, is take this plus alignment out, because we're going to fix that in a little bit. What I want to do right now is deal with this warning. So the warning is 0 extending unsigned into int pointer of greater size. So it's 0 extending in. We probably don't want it to do that. So let's just static cast. We should be able to static cast this pointer t because it's a unsigned int, and it should be able to automatically drop into a into an int pointer. There should be an inherent casting ability, so we shouldn't have to do a reinterpret cast for that. All right, that should, I'm hoping, fix our crash bug. There you go. All right, and you will see if we rebuild the solution that we only have these 5 warnings left, which is fine. These 5 warnings are from our memory manager class right here. These operator news, which are returning local variables, and that's all good. Okay, another thing I wanted to fix, or not necessarily fix, but change, and I kind of went back and forth on this a little bit, but I think I want to fix it. So in our memory helper class, remember we are using this as a base class for other classes, and as such, we probably should make the destructor virtual, like so, and that shouldn't have any effect. It's going to create a vtable for this class, but that's okay. That'll just become part of the header, so we don't need to worry about that. And so everything should be fine. Very good. Yes, another thing I want to change before we move on to the actual block, which we're getting close to. I promise we're getting close to it. In the memory manager class where we had that malloc function, I simplified this by taking, by not adding in the amount of memory required to grab the header as well as the alignment. And I did that just to make this a little bit more simple. However, I think upon reflection, I don't like that change. One of the problems with our system is that if the user requests like a kilobyte of memory, they're not actually going to get a kilobyte of memory, because we're also going to be storing the header for the memory block classes in that space. So every time they request some memory, there is a bit of overhead that's going to get used up by the memory block class itself. That the instance of that class is going to sit in there as well. So there is already some overhead. So I don't like the fact that we are all again reducing it. So what I'm going to do is I'm going to add back in size of the memory pool class. Memory pool class, there it is. And I'm also going to add in alignment -1. I won't go over the calculation in any great detail. We made this a constant. Now I can't change it. Okay, well, let's unconstant it then. Memory manager class, where did I put that? Because I'm actually changing it now. Okay, so that'll put in, so the alignment -1 will take care of the amount of space that is required for the alignment of that class, and this is the size of the class itself. So that'll take care of that. Then you'll also add in the number of bytes requested. So we're not losing quite as much memory as we were before. So that's good. Okay, let's head over to the memory helper class one more time. This I want to make a slight change to, because I decided that I kind of talked about this before. If this aligned memory was already past the point where we our original point, then we didn't need to jump it forward. We're jumping it forward anyway, or we were anyway. At the moment, we're not, because I took that out. So let's take care of that. If aligned is less than original. Now you got to be careful here. You don't want to introduce any fence post errors. If aligned equals original, it's not going to jump it forward, right? So always remember that when you call calculate aligned memory, your original is at least 1 byte past whatever it was you just ended up storing. Okay, that's the key to this. All right, then we're going to say aligned equals okay, I see a bug in my scrap code. So we're going to do this like this. If aligned is less than original, then aligned plus equals alignment. That's all we have to do. Now this is going to be a void star, so we need to change this to a void star. Ah, that's why I did that. Okay, yeah, I see what I'm doing. Okay, never mind. There's no bug in my other code. I didn't think there was because I had tested it. So what we're going to do is take the original alignment, and it's basically going to look like this, right? So I'm going to grab this one and copy it. Except we're going to change this to aligned. So we're basically just taking aligned, we're putting it into an int pointer, like such, and then we're going to add in the alignment, like such. Let's see, do I like that? See, that'll go to there. Yeah, that should work. Okay, so what are we doing here? So if aligned is less than the original, then we are going to jump it forward by 1 alignment. So it goes past the original point. So we just take our aligned, we cast it into an integer. We add the alignment, and then we cast all that back into a void, and that's what aligned is. Okay, so that should take care of that issue. I hope that makes sense. So basically, if aligned equals original, it'll return right here. But if not, it'll jump it forward 1 alignment and return that. Okay. Okay, guys. So at this point, I went into the construction of our memory block class and everything associated with that to get memory blocks working. It turned out to be quite a bit more extensive than I thought, and I went on for about an hour. So as that's already pretty long for one of these episodes, I think I'm not going to try to tack it on to the end of this, but instead I'm going to end this here, and then in next week's episode we will definitely get into that. It's already recorded. I just got to edit it down, but yeah, so we'll rather than try to make this an episode that ends up being like close to an hour and a half long, which is far too long for one of these, I'll just stop here, and we'll get into that in the next episode. Okay, let me take a minute to thank my patrons. My $5 plus patron is Michael Hilliard. Thank you very much. In the description below, you'll see a list of all my $3 plus patrons, along with any links that they've requested that I link to, so please do go check that out. And then finally, at the very end of this episode, you'll see a list of all my $1 plus patrons. Thank you very much, guys. It's really appreciated. Without your support, this would be a much more difficult endeavor, so I'm very appreciative. Okay, gang, we will stop here, and we will pick this back up in the next episode, so I will see you guys in the next one. Thanks a lot. Thanks for watching, guys. If you enjoyed this video, please take a second to comment, like, and subscribe. All these things really help me out. I'd like to say a big thanks to all my patrons whose names are appearing on the screen right now. Thanks a lot, guys. I really do appreciate it. If you enjoyed this video and you'd like to see more great content, consider joining my list of patrons. There's a link on the screen in the bottom left corner. Thanks a lot, guys, and I'll see you in the next video.